Hey DLA kiddos, so your learning target for today is I can change variables on an electromagnet to increase the magnetic field surrounding the electromagnet. Okay, so today you guys are going to be starting your at-home version of the electromagnet fishing derby. Unfortunately, you guys aren't in class to actually build this. It's a really fun activity, but we tried to make it as realistic as we can for you guys at home given supplies. Okay, so your guys' lab will be broken down into 3 days. And you have different goals for each day. So on day 1, you'll be examining the effective electromagnet fishing poles using different components like a D-cell battery, a piece of magnetic wire, and a nail. So basically, you guys will have a bunch of different variations that we could do to one of these electromagnetic fishing poles. And you'll be choosing which one you guys think will be the most effective. On day 2, you guys will collect data. So you guys will take those exact same fishing poles that you examined on day 1 and watch some videos to collect data to see which one of those are actually more effective. And then finally, day 3, you guys are going to take what you learned on day 1 and 2 and you're going to design your own electromagnetic fishing pole. Okay, so just to give you guys a rundown, this is generally what your electromagnetic fishing pole looks like. So you guys have a nail. Obviously, a nail is not normally something that acts like a magnet. Okay, I can't just touch it to paper clips and have it pick up paper clips. Okay, some different components that you see on mine is this switch. Okay, most of the kids in class will make a switch out of just paper clips and thumbtacks, but for this demonstration today, we did just these switches for you guys that you'd see in your house, just to make life a little easier. And then you guys have this bigger D-cell battery. Okay, so I have a piece of wire that connects to the end of this D-cell battery. It goes down into my nail and then wraps around my nail, coils up, attaches to my switch, and then there's another little wire that attaches my switch to my battery. So basically one 100 centimeter wire, one 10 centimeter wire to connect right here, D-cell battery, a switch, and a nail. The other component is every kid in class had some parameters. So let's go ahead and talk about those. Those are your materials right there. And then your parameters are that each fishing pole is 25 centimeters long. Okay, so from the base of the battery to where the line drops off is 25 centimeters. Okay, and then from where the line drops off to the lowest part of the nail, that needed to be 15 centimeters. Okay, so this is basically what your guys' parameters would look like. Those are your minimums. So you could go a little bit longer than that if you wanted. Okay. Each line hangs off the pole by 15 centimeters. A switch is included that can turn the magnetic field on and off. So when the switch is on, we have a current running through the wire giving us a magnetic field on our nail. Okay, when we click it off, no current, therefore this is just a normal nail. Okay, and then so that allows us to be able to catch and release fish. Our fish in this case are little paper fish with paper clips attached to them. And then in the demonstrations that you guys will see and then what the kids will do in class is they will have 1 minute to fish and compete to see who can catch the most with their fishing poles. All right, so let's move on to day 1. So on day 1, you guys are going to obviously go back. You guys have already kind of watched this. See a little bit, you know a little bit about the materials and how we put this pole together. So make sure you guys kind of review that and that you know what the parameters look like. Okay, each of these poles that you guys will see on the next couple pictures will tell you, are all going to be within the parameters, so they're going to be good poles. Examine your guys' variations of fishing pole designs. So you guys will kind of see a theme for each slide, and then there will be different variables that are tested for each of that slide. Okay, and then what you're going to do is on each side, you're going to use the draw tool to circle the fishing pole that you think will be the most effective. So basically, it's going to pick up the most fish or the most paper clips. And then explain your reason for your selection. So let's go ahead and take a look at slide 6. This is your day 1, and we're looking at the number of coils. So you guys can see a fishing pole built with 15 coils, 10 coils, and then this one has the most with 20 coils. You guys can kind of see a little closer up. You guys can definitely click and open those pictures up a little bit more, and then just undo it to put them back to their original size. So use your draw tool, circle which one you think is best, and then go ahead, click back on your cursor, click and let me know why you think that's best. Again, this should be based off of information you guys saw with the electromagnet fishing pole. So you guys should have some, I would just think it's best because it looks cooler. Okay, have some good reason why. Okay, next one, magnetic core. So you guys can see there's just 1 nail here, 2 nails, kind of a hard picture to see, and then 3 nails. And then explain why you chose this variation of cores. So which one do you think would be best and why? D-cell battery, so we got 1, 2, or 3. Okay, so here's 1, 2, or 3 put end to end. Battery type, we had a 9-volt battery. That's a little square box looking battery with the 2 plugs on the top. C-cell battery is bigger than a AA battery, but smaller than this D-cell battery here. So this one right here is a D-cell battery. Okay, so C-cell is a little bit smaller than that, but still bigger than a AA. Okay. Wire gauge, that's wire thickness. So the lower the number of gauge, the thicker you have. So this is our thickest wire, and then 28 is our thinnest wire. Okay, and then finally wire length. We used more than 100 centimeters for these. So this is our traditional pole with 100 centimeters of wire, about exactly 15 hanging off. Here's 125, and then here's 155 centimeters, excuse me, 150 centimeters of wire. Okay, so that's your day 1. Okay, that's your first day. Tomorrow, you guys will do day 2. So on the following slides, watch the linked videos testing each variation of a fishing pole. So you guys are going to have, I think, 6 to 8 variations, 6 variations, excuse me, to watch videos for and watch the data, to collect data. So here are your data tables. Right-click the video linked right here. Open that link. Remember, if you guys are having a hard time clicking, it may be because your draw tool is still left on. Watch how many fish are picked up in each test. Okay, so I explain which test. So this has all the different variations for coils in this. So you guys will record how many coils for each pole and then the number of fish caught for each. Okay, this one it'll tell you guys the core, how many nails for each, and then the number of fish caught. Video right here for battery types. So you guys will have 9-volt, D-cell, and C-cell, and then the number of fish caught, and then number of batteries, 1, 2, and 3. And then day 2 is going to be your gauge of wire. So look at those 3 different thicknesses of wire. Tell me which the gauges are right here. And then length. We had 3 different lengths there. So watch the video and tell me how many fish you caught for each of those. Okay, finally on day 3, we have just a chance to look back at our data from day 2. And say, all right, this is what our data was. Now, if I were to choose the best out of all those and design a fishing pole, what would it look like? Okay, so obviously we looked at 6 different factors. If there's other factors that you guys think would be better or you know would be better, you're definitely more than welcome to change those aside from those 6 as well. So what you guys will do then is you're going to design your effective fishing pole. You're going to draw a picture of it on a clean sheet of paper, okay? You're going to label all of your components. So I should see definitely the different variables like the number of coils, the size of the core, power source, wire gauge, wire length, and other measurements. So obviously you guys would tell me just in general how long your pole was, maybe what your drop off looks like right here. So it should be very neatly done, very clean. Okay, this is basically your guys' finished product, whereas everyone else actually built this. So you guys need to do a really good job with this drawing. Okay, then finally take a picture of your design, make sure it's clear to see. You might have to go over it in like black ink just so you can see it a little bit better. And then you're going to insert it on slide 16. So here's where you guys will put your final design here. Again, if you guys don't have any of those things labeled, I'm not going to give you guys credit for it. You need to show me the specifics of your pole. If I were to follow directions and build your pole, could I do it from looking at your picture? Okay, finally you guys have a couple follow-up questions to answer for day 3. So tell me a little bit about your guys' specifications that you used and why, okay? So go through those, give me good scientific reasonings as to why you chose to use them. Use data directly from your collection and your tables. And once you've done that, you guys are done. Make sure you turn it in, and if you have any questions, let me know. I hope you guys have fun with this as much as you guys can from watching videos from home rather than making it in class. But I hope you all are having a great day.